Hi guys, I'm Darren, and in this video we're continuing on with our INAV 5 beginners build with the Atom RC Dolphin. Today we're going to be setting up our transmitter. So again, before getting started in this video, I do need to do a couple of Patreon shout outs for guys who have joined me on the pilot's level or above, and that is Shimon Says and Mark Beswick. So thank you guys. And thank you to everyone else who's supported me as well, whether that's been through Patreon, super thanks, just liking and subscribing to the channel. Thank you all very much. I really do appreciate it. So let's now get back onto this video. So before we continue, if you're just joining us here and you're interested in the rest of the series, it's all in a playlist, and I'm basically going through step by step how to build this from the ground up and how to get INAV installed. So we'll be going from absolutely nothing to a fully flying plane, and I'm taking it at like a beginner's level so that everyone can sort of get into this hobby. That's the whole point. So if you're new to this and haven't seen the previous videos, I'll put a link to the playlist in the video description. So I'd recommend starting at the beginning and working your way through it. But in this video, what we're going to do is set up the transmitter. And we need to do this before getting the rest of INAV set up, because we need to use the transmitter to set up the rest of INAV basically. So as I've mentioned in previous videos, I'm basing this on OpenTX transmitters. So this is going to include people that use FrSky, QX7, X9Ds, Horus X10s, X12s. All those are covered. So would sort of Jumper, T16, Radio Master TX16S, all sort of the popular transmitters are covered by this. And this is one of the reasons I'm using OpenTX to demonstrate this, because to be honest, most people in the FPV hobby are using OpenTX, and you might get a few people who are using other systems such as Spectrum, Futaba, the new Ethos system from FrSky, but they're still catching up with the number of people that are just using OpenTX. And the other thing that I appreciate is that if you're new to this hobby, you aren't just new to INAV and building planes, you're also new to OpenTX. To make this even easier, we're going to use an OpenTX model that already exists, that is built mainly aimed at beginners and FPV. So let's jump over to the INAV Fixed Wing Group website and take a look. Right, so the website is inavfixedwinggroup.com, and what we're going to do is go to guides and the OpenTX models. I'm showing you in the menu because if there's an update, the latest version will be put here. And I also want to point out that I'm not doing this just to cheat. I actually made these models, so it's stuff that I've done anyway. And what we're going to do is use the standard model. Now the Pro model might sound more attractive, but if you're a beginner, just go for the standard model and get used to things first. The Pro model sort of offers things like in-flight tuning of PIDs and stuff like that you're not really going to need at this stage. We're just going to get everything up and running and flying. So what I'm going to do is download the standard model. So we click into the page, and this actually is quite an extensive instructions on how to install it, but we will be going through it in the video anyway. So the download link is at the top, so I'm going to click that and get it downloading now. So I'll just stick it on the desktop. For some reason it's gone through twice. And while that's downloading, let's have a quick look at the supported systems. So as I mentioned, these are all the radios that are supported by this model. It doesn't support the light models, unfortunately. There is a light OpenTX model, which also has a few modes, but the layout is a little bit different. The installation process will be pretty similar, but to be honest, there was just not enough popularity in the light model for me to continue putting work into it. To be honest, most people use the standard or the Pro model, so that's where all the effort was taken. But you can see basically all the FrSky transmitters are supported except for the latest ones currently. We have quite a few Jumper models, and we have the Radio Master TX16S. That obviously includes the Mark II and the Max versions. So the switch layout is basically how we're going to control the plane. Now, of course, you can go to the website and browse through this, but I just wanted to give you a quick overview of the model. So it may look a little complicated, but it's really not, and you'll get used to this pretty quickly. The first thing that we have is our arming switch, which if I show you on my transmitter as well, is this switch at the back here, the two-way switch. And The switch layout, even though they're different transmitters, for 90% of these radios it's exactly the same. There are a couple of radios where there are 2 switches missing, but if you notice, we're not actually using those 2 switches in this model, so the switch positions are basically the same. So we have our arming switch on the 2-way position at the back. This switch on my radio is different, so apologies for that. I've basically swapped these 2 over. Our switch here, SC, which is our auto level and auto tune, and then we have OSD selection on this, so we can have more than one OSD, and we'll get into that a bit later on. And also on the multifunction switch, it's actually a menu, so you hold it in, you hear what you want, which could be, for example, save. If you've done an auto tune and you want to save it, you can hold it in. When you hear save, let go, and it will do the stick command for save. All that is in this documentation. Next up, I'm going to discuss the flight mode switches, but I'm also going to go over the flight modes, because where you're new to this, you possibly don't know what the flight modes are as well. So let's kill 2 birds with 1 stone. This first switch here, SA, is our main stabilized flight mode switch. And if we go all the way up to the top, we have a flight mode called angle. And what this will do is, as you fly along, if you start doing, say, a roll, for example, it will roll, but it will go to a maximum angle, which we can set and change, but it will go to that maximum angle. And as soon as you let go of the stick, it will level off again. The same goes for pitch. It will pitch up to a set angle, and then when you let go, it will level off again. So that's quite a simple cruising flight mode. The only word of warning I have with this is don't fly too slowly. So you want to be above sort of 30 kilometers an hour. Otherwise you could risk having a stall, and if you stall in angle, it's not the best mode to get out of it. In fact, you'll want to switch this all the way down to acro to give yourself a fighting chance to get out of the stall. I'm not trying to worry you, but I've seen a few videos where people do just fly too slowly, which invokes a stall. Luckily, the Dolphin that we're building has very good stall characteristics and can actually fly very slowly. I haven't done the conversion in kilometers per hour, but my friend was flying around at 20 miles an hour, absolutely no problems whatsoever. That's just one thing to be mindful of. If we switch this all the way down to the opposite side, we're in a flight mode called acro. Now, acro is a stabilized flight mode, but it doesn't have self-leveling. So if you start rolling and then let go of the stick, it will roll and then it will just stay where you let go. So you need to roll back the other way to level off. So this is a more acrobatic, a more involved flight mode. To be honest, it's one of the modes I fly around in most of the time. The stabilization does help with a bit of wind buffeting, that sort of thing. In the middle, we have a flight mode called horizon. Now, personally, I wouldn't actually recommend flying in this flight mode. When making this OpenTX model, it was requested by quite a few people, so that's why it is in there. What it basically is a halfway between angle and acro. So I believe the default is about 75%. So if the middle 75% of the stick movement, it behaves the same as angle. So it'll bank, and then if you let go of the stick, it will self-level. If you go beyond that 75%, it transitions into acro. So it allows you to do things like full rolls, loops, and this sort of thing. The problem is, if you are inverted and then let go of the stick, you could end up in a world of trouble. So there's 2 options. Either don't use horizon, which is my personal recommendation, or just don't let go of the stick if you're inverted. So that is this switch here. Now we're going to move across to switch SB, which again should be here on the radio, but for me it's actually here. If we go down, we have a flight mode called manual. And what manual is basically all the stabilization and PID controllers are completely ignored. It's as if you're flying through a receiver. So the only thing INAV is doing is the expo that you set, the mixer, and the output. That's basically it. You are in complete control of the plane. And this is really useful for if you do have an emergency and everything else goes wrong. If you switch, it's purely you controlling everything. So the manual mode actually will override every other mode on this setup apart from return to home. If we carry on with this switch for the time being, if we go the opposite way, we have cruise. And what cruise allows you to do is just fly in a straight line, basically. It will maintain the heading that you're flying as well as the altitude. You can actually change the heading by using the yaw or the roll sticks, and you can change the altitude by using the pitch. To disable either of those flight modes and be able to use this switch needs to be in the middle. Now let's pop over to switch SD, which is return to home. If we go down, which return to home is it's exactly what its name suggests. The model will actually come around and fly home. Once it gets home, it will loiter above your head, or if you have land set, it will then go and land. I wouldn't recommend land. It's more of a controlled crash and you need a big wide open area with no obstacles in it. I personally have land set to failsafe only, so if I have a problem with the transmitter, it will come down in whatever condition it lands in. But for regular return to homes, I will just use a loiter. And loiter is exactly what we have in the opposite to return to home position. It's marked down as position hold, because at this point in time in INAV, if you go to the modes page, you will see nav pos hold or nav position hold. In INAV 6, which is coming out around Christmas time, it will actually be called loiter. So we will update that. People just generally call it loiter, but when you hear loiter, at this point in time, it is meaning nav position hold. And what that will do is fly a circle in the sky. So those are our flight modes that we have on the transmitter. So I think the next thing that we need to do is actually go and get this installed. One thing that I did forget is we also need our sound pack. So if we pop back to this OpenTX model page, we have this option down here for the transmitter sound pack. So I'm going to open that in a new link and go back to the installation guide on that one. And all we need to do is just download. So you can see there is a sound pack for EFOS and there's a sound pack for OpenTX. And I'll be downloading the OpenTX and sticking it again on the desktop. What we also need is a software package called OpenTX Companion. Now I already have it installed, but if you just search for OpenTX, it should find opentx.org, and we're going to go to downloads. And all you do is click on the latest branch, so in our case 2.3.15, and download and install Companion. There's the Windows version, Mac version, and the Linux version. Of course, some of you guys may be using EdgeTX, and that's not a problem at all. These models should work absolutely fine with EdgeTX too. Obviously, just use the EdgeTX Companion instead of the OpenTX Companion. Everything else is basically going to be the same. So what I'm going to do is just open up OpenTX Companion and get that on the screen ready. And now what we're going to do is power on the transmitter. So now that we're powered on, what we're going to do is plug in our USB cable. And what you'll get on the screen is a little menu. So we can select joystick, USB storage, or USB telemetry mirror. And we're going to go for USB storage. And once that's set, you can just put the radio down. That's all done. So the first thing that we're going to do is open up the models on our radio. If you have trouble connecting, I'd recommend trying a different USB cable. These cables can, even though they're data cables, they're not all created equal, and some are just rubbish, to be quite honest. So if you have issues connecting, seeing the USB, that sort of thing, try a different USB cable and you'll probably find it will be okay, especially a decent quality USB cable. So let's click here, and this time we're successful. We've actually got all the models that are on that transmitter. Now what you can actually do if you wanted to create a backup is go in and save as and save these off somewhere. It's probably well worth doing if you have other models on, because sometimes doing this you can write the wrong folder to the radio and lose everything. So be careful and take a backup. So let's go back to our zip file. And what we want to do is just find our radio. So for me, in this example, we're using the Horus X10S Express. So I'm just going to take that and drag it into OpenTX Companion. Sometimes this works, but not always. So let me just put it on the desktop. Yeah, okay, so if you have problems, don't do it from inside the zip file. And what we have here is this INAV Fixed Wing Group standard model version 3 file. And what I'm going to do is put that in the FPV folder. On some transmitters you don't have these different folders, but on sort of the color LCD screen transmitters you should have. So I'm going to put it inside the FPV folder. And what we're going to do now is actually quite important. So I'm going to click on it with the left mouse button and drag it. But if we come over here, if you do that, it will overwrite the model underneath it. What we want to do is do it so that it's just a line, and that will insert the model. So if I let go here, you'll see it's added it, it hasn't overwritten anything. So what we could actually do is a little bit of setup with it in Companion rather than on the radio. So what I'm going to do is close this one down, which is one step for not overwriting with the wrong models, because now we only have this one open, which has everything on it that we want. So what I'm going to do is double click on this model here, which will actually open up the model editor. So the first thing that I'm going to do is rename it to Dolphin. And if you had a picture of a dolphin on your transmitter, you could actually set that. But I haven't, so what I'm going to do is set it to something completely ridiculous. There we go, Magnus, just for the hell of it. Now we've given it a name. The other thing that we could do on here is reverse the arming switch if you prefer it the other way around. Now the way to do that is go into Inputs, and what we're going to do is go into the arm input and just turn that weight into a negative, and then OK. Once you do that, the switch is backwards, but everything else will still work as it should in the model. So I'm going to cancel that because I like it the way it is. What we're going to do is close that down, click on this box, and then we're going to do write models to radio. So just choose yes, that's going to overwrite everything. This is the bad thing with Companion. It doesn't actually give you a little message to say that it's done it. So at the moment it's still doing stuff, so I'm going to leave it leave it be, and we'll come back in a sec. Oh, there we go. So yeah, it pops up down here, models written to radio, but it flashes up briefly and it's easy to miss. So what I'm going to do is just minimize this. I'm not going to close it down, but what I will do is just move this over to the side. So what we need to do now is transfer a few more files. So what I'm going to do, you can see on this side the SD card for my transmitter. So I'm going to right click on this and do open in new window and just move this over to the side. Now the first thing you'll see is this images folder here. All we need to do is just drag that into here. There's already an images folder, and then I'm just going to choose replace the items. They're already on my transmitter, that's why. So that's that part done. All that's done is add in this INAV Fixed Wing Group image. So if you use the default model, that image will show up still. So that's all we need to do on our INAV Fixed Wing Group transmitter model, but we need to also install our sound pack. And the reason for that is the switch positions will actually give you feedback to what they are. So it's easier for learning, but also stuff like the multi-menu. So let's open up the sound pack, and I'll go over a few things in the sound pack because I have received requests for what are the sound file names, and they're actually already in here. So if you double click on this sound pack v4, these are all the file names and what they say. So it's all in there, and you can see there are even models. So when you switch to that model, we could actually have it say ATOM-RC Dolphin if we choose the IM80DO file. Sorry for these small file names, it's a limit on OpenTX. You can only have 6 characters on some radios. So to support all the radios, they have to all be 6 characters. but that's where what the file names are if you wanted to actually find that. So in SD card we have two folders. The first one is sounds, so I'm just going to drag that in and drop it, and that will copy across all the specific INAV Fixed Wing Group sounds to your SD card. The other folder, scripts, you probably won't need at this point in time. There is an INAV Lua script which you can run on the transmitter, which gives you sort of a nice overview of your telemetry data. And the sounds for that script have been replaced with the same vocal as the INAV Fixed Wing Group model. So if you wanted to do that, you can just drag and drop this scripts folder into, and it will replace the Lua script sounds with the same voice. All right, I will just do the replace just because I may have missed some. So what I'll do is I'll come back once these sound files have copied over. Okay, so the sound files have copied across. So what I'm going to do is just unplug this, and we'll head over to the desk and just have a brief overview of what we've done so far. Okay, so we have our radio, and you'll see it's still on the previous model, which yeah, it's definitely an F1 wing, isn't it? So let's select the model that we just created. So I'm just going to long press and go to model select. I'm already in my FPV folder, so I'm just looking for Dolphin, and surprise, the image is not actually on there. So we'll long press and go select model.
Switch warning.
There is a switch warning for all the switches, and also a switch on sound. Yeah, if the switches are in the wrong positions. So let me just demonstrate that. So that's power off. And apologies, I can't actually change the volume of my sound like I used to, because I needed this for something else.
Switch warning.
So you can see when we switch on the radio, we get a warning up saying that some of our switches are in the wrong place. So SA is our mode switch. Actually, that doesn't really matter. And to be honest, it's defaulting to horizon, which is not good. So what I'll do is I'll show you how to get rid of that one, because we don't need to worry about SA. SC needs to be in the middle, SD needs to be in the middle, and SF needs to be in the disarmed position. If you did reverse the arm switch, you will also need to reverse the warning, which I didn't show you. So let me just show you what we can do to set the warning correct. So everything else right now is in the right position. So let me put this into angle, and let me just demonstrate if you've changed the arm switch. So you put that into the position where it says disarmed. And what we're going to do is go into the model menu, and if you roll up so it goes to the very bottom, you'll get to these switch positions. All you need to do is just long press, and that's it. It will correct the positions. The things to be aware of is that switch SB, which is here, is in the middle. These and these two here are in the middle, and this is in disarmed. That's all you really need to worry about. What I'm going to do is actually give myself a model image, because that one didn't work. So let me just use the INAV Fixed Wing Group model image. So there we go, that's a bit better. So you would have heard when I move the switches about that it does give you feedback. So we have our arming switch.
Arming, disarmed.
And you notice it says arming rather than armed. And the reason for that is because INAV is what decides when you arm, not the switch. So when you switch it to that position, you're requesting that INAV arm. If there's a problem and it can't arm, it won't. So for example, if it hasn't got enough satellites on your GPS, it won't allow you to arm. If you're in a navigation mode, so for example, if I go
Return to home.
into return to home, if I try to arm, it won't let me arm. So there's a reason behind that, basically. So again, we have our flight modes. So let's go over it. So we're in angle at the moment, and you'll also see the flight mode is down here.
Horizon, acro.
And that is that switch. So this switch, which on your radio will be here,
Manual.
we have manual. And you'll notice in manual the trims have become active, which are the regular flight trims here. If you are an experienced line of sight pilot, you can trim the plane in manual. And then what you would need to do is land pin the flight control surfaces and zero over trims and mechanically set them correctly. You can't fly INAV with trims on the radio, so they need to be centered in all axis. Again, if you have too much trim, it won't let you arm. But as soon as we switch out of manual, the trims are disabled. So if you do fly in manual, trim the plane, when you flick to something else, the trims will not interfere with that. And the reason for that is, say for example, we're in acro now. If we had a load of roll trim, what it just thinks you're doing is that. So it will actually just start rolling the plane. Same in angle, it will try to get you to that angle. So that's why we don't use trims in INAV. So this is the cruise mode, which is just flying straight out at a target.
Acro.
And we have return to home
Acro. Position hold.
and position hold. Now, one thing that you won't know because you don't really need to know is that all these flight modes are on the same channel. That means that INAV is being told which flight mode that you want to use, rather than a lot of people set up, say this switch will be angle, horizon, acro. They could have this switch as return to home, position hold, manual, and then have these on two separate channels. And then it's down to INAV as to what flight mode you use. With this setup, you're commanding the flight mode. But because of that, we do need to have an order. Now this is on the INAV Fixed Wing Group website. So where you downloaded the model from, it does have the order. Basically this switch is last. So for this one to be used, these two switches need to be in the middle. So at the moment, this switch will do absolutely nothing because we're in position hold. So I can put that to angle, it doesn't care. With this switch, if I switch to cruise now, it again won't do anything because position hold has been given priority over cruise. If I come out of position hold, it will go into cruise, and if I come out of cruise, it will go into angle. So the other one is manual. So if I go back to position hold, which at the moment has had the most authority, if I put it into manual, it will override position hold. The only one that will override manual is return to home. So in return to home, neither of these switches are basically doing anything. And to use these switches, you need to come out of return to home. So the order is return to home, manual, position hold, cruise, and then finally this switch here. And the other important thing is the emergency modes are towards you. So in this case, return to home. In that case, manual. But also acro is actually better, as I mentioned earlier, for getting out of things like stalls than angle or anything like that. So those modes are towards you.
Auto level.
We have our auto level and auto tune on that switch. And we'll be covering those when we actually do our maiden flight. And this one here is our OSD. So we're disarmed at the moment, and I can give you an example of the menus. So what I'll do is I'll actually show you the channel monitor. So if you watch the 4 main channels here, when I do the menu, it will actually flick these channels. So again, the only one that works when you're armed is timer reset, but all the INAV ones, like the OSD menu and save, you need to be disarmed. And the most frequently used one will probably be save, so let's show you how to do that. So just hold it in.
Timer reset. OSD menu. Save.
And then let go. And you saw the channels change to the save position. If you decide that you don't actually want to do anything, just keep hold of it.
Menu. Save.
And after those beeps, you can let go and it just won't do anything. That's basically the model set up on the transmitter. Of course, the basic channels are throttle, rudder, ailerons and elevator, or if you have elevons, it's on this stick and throttle. If you're using different modes, that should work absolutely fine. I've heard from people who use mode 1 and the model works absolutely fine because it's just the inputs that change. So don't worry about that. But as far as setting up this model goes, we're basically there. There is a bit more to it. but it's set up in INAV, so we don't need to worry about it at the moment. We can do that when we do the INAV setup. The only other thing left is to bind the receivers. Now to do that, it's all in the same place. So if you hold down the model button and go right to the very bottom, what we have here is our receiver setup options. So in this video, I'm going to be using R9, so I'll be using an external module. And the same will go for if you're using ExpressLRS or Crossfire. To set the transmitter, what we're going to do is just scroll through here. So if you're using ExpressLRS or Crossfire, you would use this option here. Depending on which system you use, the binding process is slightly different. So for Crossfire and ExpressLRS, we will choose this. But if you scroll down, you'll notice that there's no binding options. That's because you need to do it on either the Crossfire module, a Lua script, or even ExpressLRS, you use a binding passcode, so you don't even need to do anything. It just, when they're powered up, it automatically connects. So I'm not going to be worrying about ExpressLRS, because if you set it up with a passcode, you will automatically be bound anyway. And to be honest, if you're using ExpressLRS, that's a bit more of an advanced system. You've had to research how to use that anyway. For Crossfire, what you should just need to do is come out of here, go into System, and in the tools you should have the Configure Crossfire Lua script. So if we click on that, it will find our transmitter. And what we'll do is go into here and select Bind. At this point, we should just need to power on our Crossfire receiver, and it should automatically bind. If it doesn't, push the little button on the receiver. You should get a green flashing light on the receiver, and then it should bind. It will then ask you if you want to update the firmware on the receiver. If it's out of date, just choose yes for that and it will update the receiver. Once that's done, it's bound. So Crossfire is actually pretty simple. For FrSky, the process is slightly different. So what we're going to do is pop back into the model menu, go back down the bottom, and I'm going to select, instead of Crossfire as the mode, I'm going to use R9. If you're using the older system with the ACCST R9, you would choose R9M, but I'm using the ACCESS system, so I will be choosing R9 ACCESS. What I then do is I still use 16 channels. The first thing to do is set a failsafe. So for INAV, we can use hold or no pulses. So I'm going to set that to no pulses. And next, what we need to do is register. So I'm going to click the button, and then what we do is hold down the little button on the receiver and power on. And what we will get is our receiver name pops up, so we can just choose enter and we're registered. So now we're going to power off, and we've got registration OK, and we're going to head down to bind. You can see we can have up to 3 receivers on this, but I'm just going to choose receiver 1 and click bind. And then what we need to do is power on, and we can choose our R9MX. I'm going to use 868 megahertz because I'm in the UK, and we have bind successful. So if we power off and on,
Telemetry lost.
we get our telemetry loss and recovered. So that's everything working from here. So one thing that we need to do is, if we're using FPORT, we need to change the receiver option. So if we long press here, we can go down into options, and what we need to do is change the protocol to FPORT. So when we set up INAV, everything will be working fine. So once we kick back out of that, it will save it to the receiver. So now this will be using FPORT rather than SPORT. If you're on the older F4 using SBus and SPORT, you don't need to do that. It's already set up correctly. So just to demonstrate, I'll switch the receiver off. If you're using the old ACCST version, you would first select your frequency, and then you would press the bind button. When this is beeping, you hold the button down and switch the power on. And once you do that, it will bind up with the receiver. You do actually get some options Don't worry about the channel 1 to 8. That's in reference to the PWM outputs, which we're not using anyway. Just choose telemetry on and that will be fine. So let me just put that back to the ACCESS just to make sure that everything's okay still. All right,
telemetry recovered.
Yeah, it's registered by, I lost the bind, so let me just rebind. There we go.
Telemetry recovered.
So at this point here, we've actually registered our receiver and our transmitter is set up correctly and everything is ready to go. There are a couple of little bits that we need to do, but we can do those in INAV in the next video. Everything on the actual radio itself is done. So in the next video, we will add the bits for INAV. Just to give you a little heads up of what we'll be doing is we'll just be copying this bit of code into INAV and that will set everything up for us. But before we do that, we need to get some other things working. If you try and do that now, you will probably find you have flight modes missing, that sort of thing. So be patient, we'll cover that in the next video. But until then, thank you very much for watching, guys. I hope you found this useful and helpful. If you did, please remember to give it a thumbs up, click the subscribe button and the bell icon to help get this video out to more people. But also it will alert you when the next video in this series comes out. Thank you very much, guys. See you on the next one. Bye.